we're going to do 2.4 notes. So you guys have already started to look at this, and really I wanted you to kind of figure out the rules, and you might have seen them last year, but the rules that we're going to be using today, which basically state, or if this here says draw a line M with the slope 3/2, so 3/2. So if I start here and I go up 3 and over 2, and I keep following that pattern, then that's my line. And to identify a line, we write at the very end of it what that line is called, so M. Then it says construct a parallel line. Kind of tricky to do this on this, but I like to, when I do parallel lines, I like to make that level. Okay, and to make a parallel line. So this line that I'm about to draw, I'm going to draw super light because it's not really part of the problem. It's just how I create it. So you want to make sure that that's nice and light. We poke here where it meets, make an arc, poke here, just pick a random spot. I'm going to pick here because it's on a point, make an arc. Okay. My line, my transversal line is not long enough, so I got to make it a little longer. Okay. Basically, parallel line is copying an angle. Okay. So I got to copy this angle up here. Why is copying an angle going to create parallel lines? Right. So use some terminology that we've learned so far. Why is copying this angle right here going to give me parallel lines?
So they'll be corresponding.
Because of corresponding angles. Okay. I'm creating corresponding angles here. Guys, let's try to focus, please. So then I made these arcs. In a sense, this is like my point A. This is my point 8 prime. Okay, I'm going to go ahead and this is my B. I need to find where my B prime is. I open my compass from here. Okay, be as precise as I can. And then I'm going to poke A prime, make an arc. I'm going to call that B prime. And then this to here becomes my parallel line. Okay. Then it says in the directions, and that point there, that line is N. And then it says find the slope of N. Okay. And if I did a good job, then my slope of N is what? Okay. So my slope is 3/2. Okay, and on this one, my slope was what? 3/2. Okay, and then it says draw a line parallel to M and N based on what you discovered. So what did we discover? And many of you I heard already saying that you knew this.
That the slopes are exactly the same.
Okay, slopes are exactly the same of what? Parallel lines. If you have parallel lines, they have the same slope. So when I ask you to make another one, all you have to do is pick a point and do the same slope. Up 3/2, it doesn't really matter. And as long as I follow that rule, okay, I can create as many parallel lines as I want, as long as they have the same slope.
Can you call that line C?
We can call that line C, sure. LMNO, sure. Actually, we don't like O because that looks like a 0. Honestly, in the textbook, they would probably call that P. Did we already know that the slopes were the same? Okay. Do we know about perpendicular slopes?
Yeah.
Okay. Oh, gosh. Steal my thunder. Okay. So we're going to make another 3/2. So you should have this drawn. Okay. And then to create a perpendicular line, So I got to pick 2 points. I do a bisector. I'm going to go more than halfway.
Does it have to be that much longer?
It doesn't. It's the only reason it's got to be more than halfway is because your arcs will not meet. So if I did it here and I made an arc, and then I poked over here and made an arc, they don't meet. So that's why it's got to be more than halfway. Sometimes when I teach this, I say that the arc has to be from here to here, okay? And the only reason I tell students that is because then it's always more than half. But it doesn't really matter as long as it's more than half so that we can get those arcs connected. So we can make one above, one below. One above, one below. Connect the dots. You guys know who Pee Wee Herman is?
Yes. It's on Netflix.
So that's 90 degrees there. I'm calling this line A. I'm calling this line B. Okay, A slope. 3/2. It's negative 2/3. Okay. So my hope was that we could discover that by constructing these, that this slope just flips, the sign flips, and one is it's reciprocal. So it's opposite reciprocal as the language. And then I said, draw a line perpendicular to A based on what we discovered. A line perpendicular to A is what to B? Parallel. So we just basically have to follow this, or we can think of that. So that would be, I don't know, pick a point anywhere. And it has to have a slope of down to right 3. And that's also perpendicular. Okay. Okay. So that's a way of discovering it if Miss McCarthy hadn't ruined it for me.
Miss McCarthy got through her stuff fast. It was great.
She was awesome.
Yeah, but she did give us a lot. Like, awesome.
So I'm going to tell her not to teach her 7th graders this year this. Anyways, okay.
Do you like my sister better than me?
Yes.
No. I knew it.
I just like telling her that.
Is your sister algebra?
All right, looking at this next one. Here's what they love to do in these geometries, and we've seen this in the other questions. They're asking about K and N. So here's K, and unfortunately this little thing blocked it. So K and N, and what have they done to try to make this harder to do?
But they added in M and Q.
They added in line M and Q, and I don't know how many times I have worked with people. I have worked with people on problems, and I say, let's rewrite this problem without the extra lines, okay? Sometimes, and when I look at these problems, can you look at K and N and imagine that M and Q are not there? If you can do that, that's really helpful, okay? Some people, when they look at this, that M being there, they can't not see it. Okay, and they'll keep going. What about Q? What is Q doing? And you go, ignore Q. It's not even in the question. It's just there to distract you. It's like word problems when they ask you something and there's these random numbers, like they put the date in there, and people go, how do I add the date? Okay.
Or when they're just like there's this one girl who's just like, you're the bus driver. You pick up one. Like,
yes. Yeah.
So there's another way you can easily see that it's not parallel, because if they're parallel lines, wouldn't they have to have the same slope?
That's exactly what we're trying to do.
That's what we
So
saw.
we find the slope of K, we find the slope of N. If they are the same, then we say they're parallel.
4, 3. The line N is 4/3.
Okay.
-4/3.
-4/3 divided by 5 bases.
So
Then
the slope,
-5/4. So they have different slopes, so therefore they are not parallel.
the slope of K, guys, there shouldn't be discussions at the table, please. So K, I'm going to pick a nice point here. I'm going to pick a nice point here. And I draw my little stair step. Okay, and I go 1, 2, 3, 4. It's not a nice point.
No, the next one. No.
The next one, thank you. So here and here. So really I need 5 and 1, 2, 3, 4. So this slope is rise over run. Okay, -5/4. Okay, and then the slope of N. Is that a nice point? And is that a nice point? Because it's ugly, can I draw it this way? So that's 3, and that's 1, 2, 3, 4. So this one's -4/3. Okay, and as he pointed out, that's how you tell me that these are parallel or not. Okay, so if these two slopes are equal, not parallel. Okay. This is review for you guys, isn't it?
You're using that?
No, I actually wasn't until now.
All right, flip over the paper. How many of you have already done this problem? Okay, you want to race? Let's go. On mark, set, go. Find J, find K, and see if you can beat me.
I don't have a back.
It's I don't have a back.
Grab another one.
What did you do for dating?
You get a high five.
I'm done.
Okay.
Yes, they are perpendicular. I knew it. I knew it just from first glance, but
Do they have?
You don't have to bring it up. Just watch on the screen. Beating me is enough of a
Do they have?
reward.
Do they have to have the same slope? They have to be perpendicular.
Hold on.
All right. I think they're perpendicular.
Put it down.
I didn't make a hole. Or I'm not using the hole.
Come on, those are people.
I have a hole, I'm just not using
I'm done. I won.
it. No, you didn't, Mark.
I beat you all.
I was done before he even started.
Sit down, guys. Sit down.
I did too.
Dalton. All right, so I got the slope of J was -3/2. The slope of K was 2/3. This gets really confusing for people. Okay, opposite reciprocal. Okay, so these are definitely opposite, meaning one of them's positive, one's negative, and they're definitely reciprocal of each other. The textbook says if you multiply their slopes, it equals what? -1. It says if you multiply their slopes, it always equals -1. Okay, and at first I looked at it and I go, oh, that's a weird way of saying it, but it's, yeah, it's true. If you multiply their slopes, it equals -1 if they're perpendicular. For every perpendicular. Yep. Because one's going to be positive, one's going to be negative, and reciprocal numbers multiply to give me 1.
I just did my cup of pizza, okay?
Okay. Writing equation parallel and perpendicular to line L. I want to point something out to you guys. that anytime that they, for lines, they use this certain font here, right here, which I couldn't get. So it bugged me that this is like a little, it looks like a 1, but it's line L. For lines, we like to use, it's actually cursive.
I do cursive.
Okay. So that's cursive, that for lines. And if I don't know if you noticed, when I drew lines back here, line M and N, that's actually how you make a cursive N, and that's how you make a cursive M. Okay. So whether you've learned that or not, I just want to point out to you that they're going to use that, and that's going to be how it's always going to be. It's just one of those things that mathematicians do. Hey guys, I'm trying to give you guys notes here. So we want a parallel and a perpendicular equation. Somebody tell me the equation of a line.
If we're doing this, y equals mx.
So they want an equation. So that means they want y equals mx plus b. Okay. And I'm always telling my 7th graders, you got to make sure you read the directions, because I promise you that half of my 7th graders would only give me one answer here, but it asks for parallel. So that's part A. And then part B is, and also perpendicular. So there's 2 parts to this. We have an equation to the line if we know 2 things. What 2 things do we need to know? The slope and the starting point, or the y-intercept, or the b, however you want to say that. Okay, so we're going to talk about how to do that, and we're going to do it in 2 steps. So step 1, or 2 parts, because there's 2 parts to the question. We're going to start with parallel. Again, we are trying to find y equals mx plus b. What of those parts do we already know? We know the m. How do we know what the m is? It's parallel, which means slope is the same. Can you stop talking? Okay, so what is our slope? Okay, so here's the slope, and we want to be parallel to this. So watch this notation. Tell me what I'm writing. M equals 1/2. What does that mean?
One parallel has a slope of.
What did this little mark mean? So that if the slope is 1/2, then the parallel. No, not m. What does m mean? So the, what is this? Somebody read this right here for me. The parallel slope equals 1/2. Okay. And when I get down to that part, I'm going to write this. Oh, can't see it. The perpendicular slope equals -2/1. Can I just write that as -2? So when I get there. So I like to write this notation because it's telling me, it's explaining what we're doing. As much as I like to not show work myself, geometry is all about explaining every step. Okay. When it's a problem and it's just solve this, showing steps I don't care about. When it's a proof, it's like, tell me everything. Okay. This is, you're correct. This isn't a proof, but I just want to show you how to express these different things. So if I ever have to say the parallel slope, this is the shorthand of that. Okay. So the parallel slope. So we know that it's y equals 1/2 x plus b. If I knew B, I would be done. So what I'm going to do is I'm going to pick a point. Well, they gave us the point. Okay, they gave us the point to work with. If I plug that point in, this is my X, this is my Y. So I say 1 equals 1/2 of 4 plus B. So now I know everything in this equation except what B is. So 1 equals 2 plus B, or B equals -1. We talked about this yesterday. Does that bug you that B is written second?
Yes.
But it doesn't matter, but yeah. So our answer is what? So there's my parallel line. I don't know, how do you feel? I have the heading up here that this is parallel. Is that enough to say that this is my parallel answer? Or should I go down here and write parallel next to it? Okay, if it was a test and it was really messy and you didn't write, that you had stuff all over the place, you might want to put that parallel next to it. Okay, and then now the next one, we basically do the same thing. This time it's perpendicular. Perpendicular. Okay, we're trying to find y equals mx plus b. We know our m. So y equals -2x plus b. Okay, we're going to plug in that point. They gave us that point for a reason because they wanted to go through there. So I got to plug in 1, 4. I'm sorry, 4, 1. So it's 1 equals -2, 4. Okay, so we get
Oh, positive. Okay, I get it. I didn't.
okay, so we get B equals 9. So our answer for our perpendicular is y equals -2x plus 9. What would be kind of a way of checking this? Let's graph these just for funsies. So if we start at, this one starts at -1. It's got a slope of 1/2. So up 1 over 2, up 1 over 2. Does it go through our point we want to go through? Is it parallel or does it look parallel? Okay.
Put the little triangles on the parallel line.
Okay, and then the other one starts at 9. Well, that's annoying. 3.
Let's just say it's right and be done.
You want? You're okay with it?
Oh, I just stopped the line at the top of the graph.
So that's where I have it. Down to 1, 2 over 1. So if I give you enough paper, it would look like that for a bigger graph. Okay, and that does look perpendicular to me.
Wait, can we just make a parallel line like this instead of doing it the other way?
So if we're constructing a parallel line using this method of slope, how would you do it?
I would do it. We just did it.
Well, you don't have a grid. All you have is a line.
Oh, okay. Never mind.
Okay, and I say, and maybe we can. That's the $1 million question. And actually, I don't want to put Rachel on blast, but Rachel got the parallel line question right and did it completely different.
Oh yeah, she made like
Oh, good job, Rachel, you're smart.
Wait, can you do it? I don't know how to do it. I don't know what that Oh
my God, Mark.
I went in the middle and then.
Mark's just quit.
Oh, I guess.
Just be a good boy like me.
So parallel line, a parallel line. So the way that we construct it is we use corresponding parts, right? Because we're going to basically have this, and then we're going to recreate this angle up here to make corresponding parts. Another way, what's true about parallel lines? What's true about a parallel line here and here? So let me say it this way. And this is how Rachel did it. What's true about this distance right here and this distance right here? And so what she did is she found a couple places where the distance was the same, and then connected those. To use the slope, how would you use the slope? Without the grid. So basically you would have to go up the same. I mean, you could make a grid, but how would you do that?
I haven't done it yet. Why are we so sassy? I'm not being sassy.
You're being sassy.
I'm not being sassy.
You're being tough.
You're not being sassy.
I'm not a sassy person.
I'm being.
You're always sassy.
I've never sassy.